Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is string deletion. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given a binary string S of size n and you can perform the following operation in it. That is, choose three indices I, j and k in such a manner that I is less than j and j is less than k, and they all range from 1 to length of the string S. You have to choose these indices in such a way that Si is not equal to Sj and S of j is not equal to S of k. Now once we have chosen these three indices such that it satisfies this condition, what we can do is we can delete the element Sj index and the rest of the string we can concatenate. We need to find the minimum possible length of the string after we perform some, possibly zero such operations. So for the input format, we have t test cases, and for each test case, we have two lines. The first line consists of integer n, that is the length of the string s, and the second line consists of the binary string s itself. As for the output, we simply have to output the minimum final length of the binary string s if we perform several of these operations. As for the constraints, number of test cases will go from 1 to 10 raised to 4, length of the binary string s will go from 3 to 2 into 10 raised to 5, and the elements in string s will be just zeros or ones since it's a binary string. Let's see some sample inputs. So for the first sample input, the binary string s is of length 3 and the string is as follows 1, 0 and 1. Now if we see the indices, we can choose this index 0, 1, 2. If we choose this and make them as I, j and k as per our condition, we can see that this satisfies it. The element at ith index is not equal to the element at j index, and similarly element at j index is not equal to element at k index. Therefore, we can delete the element at j index. So 0 will be removed and rest of the strings will be concatenated. So our s will become this, and the minimum length is 2. Because to perform these operations, we need at least 3 indices, and since the current length is less than 3, we cannot perform any further operations. Similarly, for the second test case, again, the length of the string is 3 and the string given to us is 100. Now if we see the indices I, j and k here, although we have 3 indices, they do not conform to the condition that we have set, that is, s of I is not equal to s of j. That is good, but s of j here is equal to s of k. Therefore, we cannot perform the operation. Thus, the minimum length that we can get is just 3. And as you can see, that's the answer here. Let's see how we can approach the solution. From the sample input and the condition, we have seen that we need 3 indexes, that is I, j and k. Furthermore, s of I should not be equal to s of j, and s of j should also be not equal to s of k. And if we satisfy all of these conditions, we can delete the element at j index. So it means that in the string s that we have, we cannot delete the first or the last character. Why? Because in this condition that we have, we can always only delete the element at index j, that is the middle element. So the corner ones, that is the first and the last element, we cannot delete. So let's see what can be the possible values at these corners. So one value could be that s of 0 is equal to s of n minus 1. That is, they both are either 0, 0 or they both are 1, 1. So in this case, since we already have two zeros here, in middle, if there is any 1, we can delete that, right? But similarly, can we delete any ones here? Let's see. So at the start, we have a 0. At the end, we also have a 0. In between, all the ones we can delete. So let's say we find the leftmost index of 1. And similarly, we also find the rightmost index of 1. So in between, all the elements are 0. Here also in between, all the elements are 0. So now what we can do is, since at the corners we have 1, here any 0 that we have, we can delete it. Once all of these zeros are deleted, only ones will be left. Now, Since at the original corners we have zeros, what we can do is we can delete all the ones here. So finally, we can delete all the elements in the range L to R. So in a way, since initially we started with n elements, what we can do is we can delete all the elements in the range of R to L. The same can be done if at the corners we have both 1, because this is just the change of parity. If it's both 1, we can find the leftmost 0 and the rightmost 0, and we can delete all of them in the range. Now what happens if s of 0 is not equal to s of n minus 1? So in this case, what we can have is, we can either have at the corners 0 and 1, or we can have at the corners 1 and 0. So let's check the case of 0 and 1. So at the start we have 0, and at the end, let's say we have 1. So now what we do is, let's say we find the leftmost one. So this is the leftmost one that we have. Similarly, let's find the rightmost 0. Now that we have this, what can we do? So we know that in between here, all of them will be 1, because this is the rightmost 0. Similarly, all the elements here are going to be 0, because this is the leftmost one. So now in between these two ones, we can delete all the zeros that are going to be present here. Similarly, from this 0 to 1, we can delete all the elements that are 1. That means all the ones that are here we can delete. We have already know that here we only have zeros and here we only have ones. So in between this, we can delete all the zeros because we have at the corner 1 here, and we can also delete all the ones that we have due to these zeros. So this section we can delete. So finally, the elements that we are going to be left with is all the zeros here and all the ones here. So for this, our answer will be nothing but, from here let's say we take n minus 1 elements, and at the end we'll take all the elements between n and r. So with this, we'll have all the elements that are left. We cannot delete any further. So with these conditions, that at our corners, if we have the elements of same parity, we can simply find L and R and subtract it from N, and that is our answer. In case we have different parity, we can find the leftmost one and the rightmost 0, and we will delete all the elements in between. Whatever is left, we cannot perform any more operations. So with this, we'll get the minimum length of the string that will be left after performing several of these operations. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and the input of our string s. Now as we have seen in the approach, if we have the element at the corners of same parity, we can perform such operations. And if they are different, we'll perform another kind. So our approach will depend on the elements that are at the corners. Now if both of the elements are of the same parity, then whether it's 0 0 or 1 1 at the ends, it doesn't matter, we can perform the same operation. So what we will do is, we'll choose to go with that. At the start we always have 0. If that is not the case, what we can do is, we can flip the parity. Even if we flip the parity, the amount of zeros and ones will remain the same. So we are free to perform our operations. So with this in our mind, let's move ahead. So first operation is when at the corners we have the same elements. So in this case, since we have flipped, we are always sure that at the start and at the end we have 0. So once we have this, we go over all the elements and find the leftmost index of 1 and the rightmost index of 1. Now if L is less than R, it means that there are some elements in between. So if we have those, including those ones, we'll delete everything. And whatever we are left with is the minimum length of our string that we can get after all operations. Now, for the other scenario where the elements at corner are of not same parity, that means in this case there will be 0 and 1, because if there are 1 and 0, we flip the parity and make it 0 and 1. So if we have this, we are going to find the leftmost 1 and the rightmost 0 apart from the corners. Once we have this, we check whether there are elements in between or not. If there's any element in between, we can delete all of them, and the only thing that will be left with is from start to the leftmost one, or from the rightmost 0 till the end. At the end, we print this, and as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. take the input of n and s. Now if our string starts with 1, what we are going to do is we are going to flip all the characters, change 0 to 1 and 1 to 0. Now moving ahead, if at the corners we have same parity, what we do the similar thing. We find the leftmost one and the rightmost one, and whatever is in between, including these, we'll delete. Whatever we are left with is the minimum length of the string. If we have different parity, we find the leftmost one and the rightmost 0. Everything in between will be deleted, and only thing that is left will be our answer. And as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.